Greetings, welcome Datacom students, level 4. As we agreed, the understanding of the layers is very, very important, very critical in the whole networking course. So as we are starting this, as we are moving forward with this networking course, it is important to be very clear on the layers using the OSI model. OSI, Open Systems Interconnect model. OSI stands for Open Systems Interconnect, which means this is an open system. Anyone willing or thinking of designing any device that is going to participate in any network must know and understand and implement the this mode of layers. Very, very important. I will take an example. I'll give you an example so that the concept may become clearer as we go on. I'll give you an example of the posting a letter from one person to another. Actually, the concept of layers is common in our daily life. Let us consider you want to send a letter, as I said earlier on, and you are going to use the postal system. You definitely need some system to be in place, otherwise it will be very complex. But because there are agreed systems between the sender and the receiver, and then we also have a carrier, and there's a hierarchy to follow. These things are already established, so it's not going to be very complex. Let's quickly go through it. Exactly what I meant. As we can see from that diagram, we have got a sender, and we are supposed to send a letter to the receiver. The receiver is supposed to receive the letter. I'm just introducing the concept of layers, that each stage is a layer. Like the first layer there, the letter is written, then you put it in an envelope, you put it in the mailbox. That's the first layer. The second layer, the second part, the letter is carried from the mailbox to a post office. The letter is delivered to a carrier by the post office. Then the post office takes it maybe to another city or to another country. Let's say to another city. Let's say it's from Johannesburg to Cape Town. The letter is delivered to a carrier by the post office. So the post office in Johannesburg takes it to a carrier who carries the letter to a certain center in Cape Town. From Cape Town, post office or the center, the letter is now carried to the mailbox. From the mailbox, the person will pick up their letter. So in short, that is how a letter moves. As you can see, there is levels. Each one does their particular part. Each one is assigned a particular task to do so that the letter moves through the system. This is similar to what we are going to observe using the layers when we are communicating using layers in networking. This is very, very similar. Let us now go. Because of the need to standardize communication between devices or between computers, the OSI model was established in 1947. It is a multinational body dedicated to world agreement on international standards. Internationally, they had to agree how information must move from one device to the other until it gets to the receiver, just like what we saw on the post office. So in other words, an ISO standard, International Standards Organization standard, covers all aspects of network communication in an open system. This, according to the history of networking, was first introduced in the late 1970s. Um, the OSI model, which is well known to most people today, was developed in the 1970s. This is when computer networking was just starting to gain traction. Computer networking was just starting. Remember, these developments, they came after the Second World War. The Second World War ended in 1945. So 1947, these things started happening. Then by two distinct models were combined in 1983 and published in 1984. There were several systems which had come up after the Second World War, but these were, because of that international organization, they were combined and they were published in 1984. The OSI model is often described from top to bottom, meaning that we start describing it from the application layer down to the physical layer. But for the purpose of this presentation, I'm going to start with the physical layer, and then I'll go up, physical layer being my layer number 1, then my data link layer number 2, going up like that until I get to the application layer, which will be my layer number 7. So me, I'm going to start with the bottom and go up. Point of caution, remember, we are talking of two things here. ISO is the International Standards Organization. It's the organization. ISO, International Standards Organization. And then if you reverse that letter, you just reverse it, it's now Open Systems Interconnect. So it's the same word reversed. So I used to get confused at first, but please let us just take note that the ISO is the organization. Then OSI is the model, or is the technical on the ground now that actually does the networking. So please take note of that. Don't confuse the two. As I said earlier on, um, at the bottom, we have the physical layer, and those are the layers listed there, the 7 layers of the OSI, Open Systems Interconnect. Those are the 7 layers, starting from with the physical. So I will start with the physical and go up until we get to the application. What are we doing here? We are looking at the interaction between the layers in the OSI model. We are looking at the interaction between the layers in the OSI model. As you can see there on that diagram, it might not be very clear there, but I'm trying to present to you the physical layer at the bottom. Then we go to the data link layer, and then we go to the network layer, and then it goes up transport, session, presentation, and application. So in brief there, you can see some of the functions in short. But let us go into detail now. As we are digging a little bit deeper into the functions of these layers, we can see that at the physical layer there, we are talking of the transmission medium or the wire. It can be the optic fiber, it can be the coaxial cable, it can be twisted pair cable, or it can be the Wi-Fi using radio signals. Still at the bottom there, the physical layer is talking about the actual transmission medium, the one that transmits the electrical pulses, the ones and zeros. Of course, remember, we do not transmit ones and zeros as such, but those ones and zeros are changed into frequencies or electrical signals so that they can travel through a wire. You can't transmit a 1 and a 0 as it is. You have to modulate. There's a process called modulation, which converts a 0 to a certain frequency, a 1 to a certain frequency. On the receiving end, that frequency is converted to a 1 respectively and also to a 0. So at the physical layer, you can see that everything has been combined. It's full. It's the largest packet, if you may say. As you can see, as we go up the layer, we are going to be taking out some of the packets, and the data is going to become less and less until we get to the topmost layer. It will make sense as we move up this layer. So we are going to, as we have seen in the previous slide there, we are going to cover physical layer, data link layer, network layer, transport layer in that order. We are going to be very brief. These are the layers of the OSI model. These are the layers of the OSI model. The physical layer, ladies and gentlemen, the transmission medium. Physical layer refers to the transmission medium, the cable, where the electrical signals are actually sitting on. On the left-hand side, we are getting it from the data information from the data link layer. It goes into the physical layer or into the wire, and then it's transmitted, whether it's an optic fiber or a twisted pair or an Ethernet or a satellite signal or a radio signal or a Wi-Fi. It doesn't matter. But it's the one that we use to carry the signal from the sender physically to the receiver. As remember, on the computers, what we mean is the network interface card is the one that interfaces with the physical medium, the network interface card, where we plug in our Ethernet at the back of the computer there. That is where the computer is now sending information to the physical medium. That is the physical layer of our OSI model. In short, the physical layer is responsible for movements of individual bits from one hop or from one node to the next. When a networking issue arises, a lot of networking experts jump directly to the physical layer to make sure that all the cables are connected correctly. For example, that the router, switch, or computer's power plug hasn't been disturbed. Why? Because if this layer or if these cables are disturbed, it means everything else will not function. So most professionals, they have their eyes open. As soon as there's a problem, they'll first check the physical layer to make sure that at the physical layer, everything is okay and the bits or the information is able to move from one point to the next. If there's any disconnection there, then it will cause problems to all the other layers at the top, because they depend on the physical layer to receive whatever they are supposed to receive. We now move on to layer number 2. Layer number 2 is the data link layer. Remember, the physical layer is just a wire carrying data from one place to the other. It does not have any logic. It does not have any processing power that it does. This is done now by the data link layer. What does the data link layer do? Data link layer is the one that manages the error correction from the physical layer and offers node-to-node data transport between two directly connected nodes. Remember, a wire cannot do error correction. You now need another layer to take care of the error correction. The media access control layer and the logical link control. Remember, the MAC address is the address of the hardware address of your computer. That is, every network interface card is holding what is called a MAC address or a media access control address to identify these from one computer to the other. Most switches in the networking industry function at layer number 2. This is where most of our switches or hubs, they function at layer number 2. Remember, they are taken from a wire and then we go into a hub. And a hub or a switch is now on layer number 2. It's not that quite easy. In order to allow virtual LANs that may cross several switches and subnets. Some switches additionally function at layer number 3. This is remember we said switches are intelligent hubs. Switches are intelligent hubs. So some switches have got a functionality which encroaches into layer number 3. Layer number 3 is concerned with the routing or routing. That is the function of a router. But that is now layer number 3, which means our hubs and our switches, let's just say our switches, they operate on layer number 2 because they help to do error correction. They also help to regenerate the signal to sort of act as a repeater of some sort, so that as the information goes now to the next layer, number 3, it is free of errors. If the signal power has gone down a little bit during transmission, it is now back to normal, so that layer number 3 does not have to struggle. Error correction is done at layer number 2 so that they present an almost error-free signal to the next network, which is the network layer. Let us see what the network layer does. Okay, just before we jump to the network layer, remember the data link layer is responsible for moving frames from one hop to the next. We are now talking of frames, which means we are now looking at what that cable was carrying. We are now going inside and we are now doing some processing and seeing at the frames. So one frame must be transmitted from one area to the other. If there's an error in the transmission, it is the work of the layer number 2, which is the data link layer, to do those corrections, as we saw earlier on. So now these frames are now sent over to the network layer, which is layer number 3. Just to clarify, we are hearing another terminology called hop or node. What we simply mean by that is that from one hub to the next, that's a hop, or from one router to the next, that's a hop. For example, we are moving from one computer lab to the college, one computer lab of the college to the head office where the main router is. That's a hop. But sometimes, because the computer lab is number 10 and we have got 7 other computer labs in between, which means that the number 10 lab must move to number 9, must move its signals to the router in number 9, and then the router in number 1 must see another switch in number 8, and so forth until it gets to the router in the headquarters. So those are called hops. Those are the ones which are referring as hops from one device to the next. So that is the purpose of the data link layer, to make sure that those packets or those frames, they are transmitted from one node or from one hop to the next. We now at the network layer, which is layer number 3. We have transmitted the electrical signals at the physical. We put it in the data link, error correction was done, regeneration, the signal was amplified to its normal level. Now in the network layer, here, the majority of the router functionality, remember at the routers, that most network experts worry about, and a door can be found right here at the network layer. In the simplest terms, ladies and gentlemen, this layer is in charge of packet forwarding, including routing across several routers. Now it has got data which has been corrected from the layer number 2. Now it is now supposed to send it where it must go. Remember, routing or routing is when the router sends packet A to a certain destination according to the IP address. Now we are now talking of IP addresses here. Remember, we are routing. So we are saying this packet must go towards Johannesburg. This packet must go towards Cape Town side. This packet must go towards Bloemfontein side. That is the job of layer number 3. We are now concerned about routing or routing or packet forwarding the packets to the right destination. Remember, packets don't necessarily have to follow one route. There are several alternative routes that packets can follow. The layers routers make it easier to accomplish this. This is what the router does. It looks for the best route where it can send the packets so that it can get to its destination. But don't worry, routing is another lesson on its own. We will discuss routing in another lesson. Emphasize before we leave this layer, just to emphasize, the network layer is responsible for the delivery of individual packets from the source host to the destination host. We are talking of packets now. Just like the letter in the first example, the letter has got an address. A letter must go to its owner. Someone somewhere must read the address that this letter is going to Cape Town, this letter is going to Kimberley, this letter is going to Durban, this letter is going to Johannesburg. The same thing happens at the network layer. We are now reading this packet must go to router A. This packet must go to network in Kimberley. This packet must go to a network in Cape Town. That is what the router is doing now. It is now responsible for the delivery of individual packets from source host to the destination host. So routers are very, very important. They are the heart of our networking. Without routers, we won't have a network. So that is what routers are doing. Reading the destination address and forwarding the packets to the relevant addresses. So as I said, without routers, our packets or our information or our data will not get to their destination. So we need routers to know where to send which packet. We need the routers are playing a very, 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 very important role there. As you can see there on that diagram, from the physical, we go to the data link and we go to the network layer. And then from those three, A, B, C, D, E, F, they are representing a node. Node A sends to node B, sends to node E, sends to node F. You can see that this information is not going up to go to the presentation layer because it's still going to another destination. The router is now responsible for directing it where it must go. It cannot go, once it goes to the up the other layers, it means it has arrived. It means it has arrived. Let us see in the next. We come to the transport layer. We come to the transport layer. Now, from the network layer, we go to the transport layer. What is the transport layer doing? Remember, the network layer is just saying this data must go to Cape Town. But how is it going to be carried over to Cape Town? That is where the transport layer comes in. That's why it's called a transport layer. The transport layer now packet size or break down that information into small kanyana pieces, and puts in headers to identify that data before it gives it over to the session layer. So the transport layer is breaking down the packets that they got from the network layer. The coordination of data transit between hosts and end system is handled by the transport layer. How much information should be sent, at what speed, and to where? That is what the transport layer is doing. The transmission control protocol, the TCP, which is contrasted on top of internet protocol, is now at work. From the transport layer, we can now see that TCP is now at work. Without TCP, we will not have a transport layer. The IP addresses that we talk about, they operate at layer number 3. Remember, the router must have IP addresses. So the transport layer already taking data that has got IP addresses on them. IP addresses, they operate at layer number 3 so that the routers can route the data. The network layer, that's where the IP addresses operate. Now, transmission control protocol, it operates at layer number 4. Transmission control protocol operates at layer number 4 because it must divide the data into small packets for transmission. You can't transmit the data as one big packet. No, you can't. You have to break it down and send it to the receiver. So layer number 4 is where TCP operates. IP is operating at layer number 3. That is where you identify the IP addresses. I hope it's making sense, guys. I hope it's making sense. Emphasizing, ladies and gentlemen, I'm just emphasizing this fact. The transport layer is responsible for the delivery of a message from one process to another. I'm just emphasizing so that when we go to the next layer, which is the session layer, the 5th layer, it makes sense. Let me expand a little bit, just to make it a little bit clearer. Let me expand a little bit here. As we can see there are 2 computers connected via an internet. What is happening there? Network layer host-to-host delivery, transport layer process-to-process delivery. Can we see that? There's an internet there, and then host-to-host delivery is done by the network layer. Remember the network layer, layer number 3, router to router, router to router. And then the transport layer is just above. It's just above the network layer. It does the process-to-process delivery. It's just trying to clarify this. I'm just hoping this is making sense. I'm just hoping this is making sense. So this is how these layers work. Each layer, as you can see, has got a specific purpose or a specific function that it is doing to enable the transmission of data from one node to the next. Let's go to the welcome to the 5th layer, which is our session layer. Ladies and gentlemen, a session must be created at the session layer whenever 2 computers or other network devices need to communicate with one another. What is a session? 2 stations must agree that they want to communicate. 2 people must agree that they want to communicate. When you phone me, I will answer my call and I say hello, and you say hello. That is an agreement that we are talking to one another. This is similar to what is happening at the session layer. So at this layer, at the 5th layer, tasks include session creation. We are creating a session. Like when I say hello, we are already creating a conversation over the phone. In this way, in the OSI model, we call them handshakes. What happens here is that host A will say to host X, I want to transmit. Host X will say, I'm ready. And host A will say, there I transmit. It goes on like that. There must be a 3-way handshake. We'll talk about that later. But what I just wanted to establish is that the session layer is responsible for a coordination of the communication between the 2 hosts. That's why it's called a session layer. A session. We are in a session. We are agreeing to communicate from one host to another. Just to clarify again, the session layer is the one that is responsible for synchronization. The same thing like when I gave an example of a telephone call. You can't all be talking at the same time when you're phoning each other. Another one is going to be listening, another one is going to be talking. So you must give each other chances. If you talk all both of you at the same time, this one is talking, this one is talking, you won't hear each other. This is the purpose of the session layer. It is going to control the dialogue between the two devices and also to synchronize the transmission between the two. Otherwise, there will be confusion. Same way as when you phone me, I must give you time to say hello, then I say hello. Then I say, how are you? Then I also, you give me a chance, then I say, I'm fine. Something like that. That is what the session layer is doing. That is what we are saying there. The session layer, ladies and gentlemen, the session layer is number 6, is number 5. It must give into the next layer above it, which is the presentation layer. It must feed its data to the next layer above it, which is the presentation layer. This is the region where that is not affected by how data is represented as application layer. In general, the presentation layer donates the preparation, the translation or conversion of application format to network format or vice versa. Remember, this data is coming from a network. It's not yet ready for consumption by the user. It must be converted. It must be translated to a language that you and me can read on our screens or can use. To put it in another way, the layer presents data to the network or the application. The presentation layer presents data to the application. For example, it presents data to the browser for the browser to show it to me. The browser is my application. So the presentation presents data from the network to the browser. It is now the duty of the browser to take that information and present it to me. That is what the presentation layer is doing. Data encryption and decryption for self-transmission is an excellent illustration of this. This takes place at this layer. Encrypting of data. Remember, if you don't have a certain decryptor of the data, you can't see it. Although it's presented to you, but the presentation layer is the one that converts the data from network data to data that can be used. So the presentation layer is the one that encrypts the data and decrypts the data for the user to be able to read it. I'm sure it's making sense. I hope. In short, in a nutshell, the presentation layer is responsible for the translation, for the compression, and encryption. Remember, we compress our data before transmission, and we decompress at the receiving end. All this is the job of the presentation layer. All this is the job of the presentation layer. Compression and encryption, decompression, etc. All this is the job of the presentation layer. The topmost layer is the application layer. This is the layer that now talks to us. This is the layer that we talk to when we want to talk to the other. This is the layer that we understand. This is the layer that speaks human language. The data comes from the presentation layer to the application, and then the application converts that whatever message to the human language that the human being can now interact with the computer system. So in the OSI model, the layer closest to the end user is the application layer. It displays incoming data to the user after directly receiving information from users, which means it also receives information from the users and converts it to data that it sends to the presentation layer. And then the presentation layer goes to the session layer. It goes like that until it gets to the physical, and then it's sent through to the next. In the next computer, again, it starts from the physical, goes to the data link, goes to the network, transport, session, presentation, and application again. So that is how these computers communicate. Instead, in order to communicate with apps on the other end, the layer supports communication through lower layers. So, ladies and gentlemen, this is our final layer. This is where we get our web browsers, where Google Chrome, Firefox, Safari, and other softwares like Telnet and all those other applications that we get on our computers. They are on the application layer, which is the seventh layer, So this concludes our layers. I'm just hoping it makes sense. I'm just hoping. So after all the hassles and all the movement from physical layer through the other 6 layers, it is the application layer which is responsible for providing services to the user. It is the browser that the user interacts with. To the user, the transport layer is not visible. The physical layer is not visible. The session layer is not visible. What the user sees is the application layer, where they are now interacting with the browser. That is what happens there. So in short, this is how your transmission happens. From the physical goes up to the application, and vice versa for the other direction. Let us quickly recap before we close off. Quickly recap. We're starting from the physical. To transmit bits of a medium to provide mechanical and electrical specifications. The speed, how are we going to transmit the data? Is it going to be over an optical fiber, over a Wi-Fi, or over copper? That is what the physical does. The data link layer to organize bits into frames to provide hop-to-hop delivery. Remember, data link layer, error correction, etc., and organize bits into frames. We are now framing the bits so that they can now be addressed in the network layer, because these packets or these frames must now be addressed so that they can be sent. Move packets from source destination to provide internetworking. Now in the network layer, remember, this is where we get our routers. This is where we are now attaching the IP addresses to the packets, the destination address and the source address, before we send them to the packet, to the transport layer, which provides reliable process-to-process messaging, or which provides breaking up the packets or the frames into smaller Kanyana bits. And remember, addresses have already been attached. And then we establish a session between two different nodes, the transmitter and the receiver. That is layer number 5. We are now establishing what? Session, and managing that session, starting it and terminating it. And then after that, from the session, we now present our data to the presentation layer for translation, for compression, for decompression, before we submit it to the user, so that the user can read his messages, can read his emails, can see his YouTube video, or can upload his things, and it goes the other direction. So this is just a summary of what the layers are doing. So I'm hoping, ladies and gentlemen, that this is making sense. I'm sure it will make some sense. Let's try to visualize it. Let's try to repeat it and research on it, so that we understand what each layer is doing. Because your understanding of these layers will help you in your networking career. If you don't understand the layers, what they are doing, and I talked to you about a router, what a router does, you will not appreciate what the router. And I say to you, let us configure a router. You will not understand what we are doing. What are we configuring? So now that we have an idea, it helps. If I say, let's connect a switch, you really know that a switch reduces network congestion because you understand what the switch is doing, that it's working at layer number 2 at the data link layer and is doing ABC. So, ladies and gentlemen, very, very important for us to master the layers of the OSI model. The OSI model is very, very important for us to understand it if we are to grow as network professionals. Just on a closing note, let me just mention this and I'll close it there. The TCP IP protocol suite, the layers in the TCP IP protocol suite do not exactly match those in the OSI model. I think I did highlight it when we were in the multimedia class, that in multimedia, we are looking at the protocol suite with 4 layers against the 7 layers of the OSI model. So the 4 layers are host to host, host to network, internet, transport, and application. However, when TCP IP is compared to OSI, we can say that TCP IP protocol is made of 5 layers. So I will leave it here. We'll explore more on the TCP IP protocol. But for now, the major purpose of this discussion was for us to understand the 7 layers of the OSI model. But I just thought I should highlight something about the TCP IP protocol suite, which we use in multimedia. We will go deeper with this in the lesson of multimedia. But for now, thank you very much. Let us stop here. Please, let's continue studying until these things are clear. Thank you very much. Thank you.